This is our video for Thursday, May 7th for pre-cal. Our objective is geometric series. Your book needs to be open page 579. So just to review, we talked about arithmetic sequences on Monday, the sum of an arithmetic sequence on Tuesday. Yesterday we talked about geometric sequence. Today we're going to talk about geometric series, which is really the sum of a geometric sequence. All the homework's due by midnight tonight, and we will have our quiz tomorrow over 8.2 and 8.3. So on Tuesday, we learned that you could take an arithmetic sequence and add it up, and so that's what we're going to talk about today. And if you look on page 579, you see another blue box, and it says the sum of a finite geometric sequence. So again, this works for finite. It means it has an end. And they have this really weird notation. They have the sigma there, but what we're interested in, I'm going to present it in a little bit different way. I'm going to change it just a little bit. You want the sum of in terms of a geometric sequence. You're going to need to know the first term, and you're going to multiply by 1 minus r to the n power divided by 1 minus r. So a sub 1 is the first term, and r is the common ratio between the terms. So again, this only works for geometric, and then n is the number of terms. So this formula, it's really kind of strange. You're going to take 1 minus the ratio to the nth power and divide it by 1 minus the ratio to the first power. So let's go on over to page, let's see, 583, and let's look at number 45. It says find the sum, and so we have our sigma notation. And remember, sigma notation just means add them up. And they want us to add up the first 9 terms, and they're giving us 2 to the n minus 1. All right, so we need to make sure that it is geometric first. And so when I put in 1, I get 1 minus 1 is 0, and 2 to the 0 power is 1. When I put in when I put in 2, I get 2 to the first power, which is 2. When I put in 3, I get 2 squared, which is 4. And so you can see that we're multiplying by 2. Let's just do one more. When I put in 4, I get 2 to the third power, which is 8. So this is geometric, and the ratio is 2. And so to find the sum of the first 9 terms, I need to know the first term, which is 1. And I need to take 1 minus 2 to the 9th power over 1 minus 2. And you can put all that in your calculator, and you will end up with 511. So if we had continued to write out all 9 terms and add them together, we would get 511. Again, this formula works for geometric. We had a different formula for arithmetic. They will both be on the quiz. Now you're at home, so you don't have to worry about memorizing. You can use your notes. That will be fine. Now, this was finite. You can find the sum of some infinite geometric, but they have to be a special type. So just flip back for a minute to page 580, and you will see a blue box that says the sum of an infinite geometric series. Now, let's talk about the difference between a sequence and a series. In our Algebra 2 book, a sequence is just numbers in order. So like a sequence would be 1, 2, 4, 8. A series is when you take the numbers in a sequence and you add them together. So this would be a series, this would be a sequence. And in the Algebra 2 book, they called what we did on Tuesday arithmetic series, because we were adding up, we were taking the sum of an arithmetic series. So we were adding up the numbers in an arithmetic sequence. I don't know why the pre-cal is just kind of one of those little differences in terminology, but the series just means you're adding them up. We've been doing that. That's what we did here. So this could be the sum of a finite geometric series. Okay? Anyway, the formula says that, first of all, your ratio has to be less than 1. And we'll talk more about that in a minute. And if you want the sum, you are not going to have an n term because it's infinite. But if you want the sum of this infinite geometric series, you're going to take the first term and divide it by 1 minus r. And so really the only difference in these two formulas is you don't have this top part in the numerator when you're talking about infinite. Now again, this only works if your common ratio is less than 1. So let's talk about that for a minute. If we look at example 8 on page 581, we have 3 plus 0.3 plus 0.03 plus 0.03, so forth and so on. So we're getting smaller and smaller and smaller. So let's talk about what's happening here. If we want the common ratio, we're going to take 0.3 and divide it by 3, and that's going to be 1/10. And so basically 3 divided by 10 is 3/10. 3/10 divided by 10 is 3/100. 3/100 divided by 10 is 3/1000. So we're basically dividing by 10 or multiplying by 1/10 each time. Well, that number is less than 1. And these numbers are getting smaller and smaller and smaller and smaller. Now, if I were to add these up, 3 plus 0.3 plus 0.3, 3, 3. So this is getting smaller and smaller. We're just basically putting a 0 in front of 3. If you add all that up, it's going to basically be 3 1/3. And so it's kind of leveling off. This is very similar to the idea of the horizontal asymptote that we talked about back in chapter 2 when we had our rational functions like y equals 1 over x minus 1. And so this quantity, as x got larger and larger and larger, the fractions got smaller and smaller, and we would say that the horizontal asymptote was 0, that it was just kind of leveling out, getting closer and closer to 0. So this one started at 3, and then you're adding 0.3 and 0.03. And you're adding these very, very small quantities, and so it's just going to get closer and closer to 3 1/3. Now that's thinking it out. Let's use our formula, which said that if we wanted the sum of this series right here, we would need the first term over 1 minus r. So our first term is 3, and our r is 1/10. And so we would have 3 divided by 9/10. And when you multiply that out, you end up with 3 1/3. And so you'll get the same answer that way, because you can't reason all of them out like we were able to on here. So let's go back to page 583 and look at an example. Let's look at number 59. And it says, find the sum of the infinite geometric series if possible. If not possible, explain why. All right, so we've got our old friend sigma, and we're starting at n equals 0, and it's infinite, and we have 1/2 to the n power. So 1/2 to the 0 power is 1. 1/2 to the first power is 1/2. 1/2 squared is 1/4. And then we would have 1/8, so forth and so on. So basically our r value is 1/2, which is less than 1. So we can use our formula. And so they want to know the sum of this infinite series that's 1/2 to a power. And so we're going to use our formula that's right here. And we're going to take our first term, which is 1. and we're going to divide it by 1 minus 1/2. And so 1 minus 1/2 is a half, and 1 divided by 1/2 is 2. And so when we take 1 and we add a half, we get 1 1/2, and we add a fourth, we get 1 3/4, and then we add a little bit more, and then we add, so we're adding, like the next thing we would add is 1/16, so we're adding smaller and smaller fractions. And so this would be getting closer and closer to 2. And this is the idea that if we had been in school, we would have explored farther in chapter 11 with the idea of limits. So those of you that are going to join me in calculus next year, we're going to take this idea of how this is getting closer and closer to 2, which is, again, the concept of limits, also the concept of horizontal asymptotes, and then we're going to expand on that and turn it into calculus. So I hope that you guys are joining me next year. All right, your work for today is on page 583. I want you to do number 46, 50, 60, 66, 72, and 91. Now, for those of you that are taking calculus and you're wondering about the limits, again, I usually do that at the end of our semester in the spring, and that makes our work easier in the fall, but we are unable to do that, so we'll just include it in the fall, and we'll be fine. It'll just be new to you instead of just a review, so we'll just have to slow down a little bit, but you will be fine. Now, today is our last new material for this year. Our next, let's talk about tomorrow is your quiz over 8.2 and 8.3, and Zoom will be at 10 o'clock if you have any questions, and then I'll open the quiz, and the quiz is going to be like a normal quiz. It's not Schoology. I didn't enjoy those very much, and so be sure and send me or email me your pictures. Now, the next 2 weeks, they want us to do something different, something more along the line of project-wise, and so the math department is coming up with different ideas, and you're going to be able to pick and choose what you want to do, so it's going to look a lot different. So tomorrow's your last quiz for the year, and today is your last new material. And so I've enjoyed the year. I wish things would have been different. Hope to see you next year in pre-cal, and you guys have a good summer.